Welcome to the HVAC-ology experience, where we talk about all things HVAC industry, topics that are so hot, they are cool.
We are in episode 12 of HVAC-ology. I would like to welcome my lovely co-host, Kelly Patterson. Hello, Kelly.
Hello, Ryan Hudson, my handsome co-host. I can say that, right?
Oh, I am blushing right now.
You
Oh my
should
goodness.
be. You should be.
Kelly, before we get too far into this, because we're getting better about this, what should people do?
They should follow our podcast. They should
Yes.
like it. They should subscribe. They should talk to us. They make comments. Tell us what kind of podcast you want to hear about.
Man, Kelly,
Right? Do
I
all
love
the
it.
things.
I love
too.
it.
Me too.
So I think you have some interesting things to run by me. I'd like to hear those.
So I do. So
Okay.
I was thinking about how incredibly, terribly, horribly hot it's been lately.
Mm-hmm.
And I was just curious about what the highest recorded temperature ever has been on Earth and where it was. Do you know that?
The hottest temperature ever recorded. I'm gonna go equator-ish. I'm gonna go something like maybe Cuba-ish, maybe
Mm,
desert, maybe like in Egypt area.
Definitely desert, but not Egypt.
Okay, I give up. Where?
Death Valley,
Okay.
134 degrees Fahrenheit.
Wow.
Right?
All right,
Like,
this is an HVAC podcast. What was the wet bulb?
oh man, Ryan Hudson, I have no idea. Don't ask me those engineering questions. The dry bulb, however, was 79.2. No, I have no idea what the dry bulb was. No.
The dry bulb was 134.
Is
You
it?
had it.
Is that what
Yeah.
it is?
Yeah,
Well, that's
ambient
easy.
temperature. Yeah.
Now I feel stupid.
Don't you say that, Kelly.
No negative self-talk. Right.
No negative self-talk.
Yes.
Very good. So we have gone down rabbit trails before. Do you have another one for me?
Okay, so when I was searching for that little tidbit, I
Yes.
then stumbled. There was an article that popped up about the Bronte sisters. This has nothing to do with HVAC, right?
Yeah.
So
Go.
So the Brontes, like they all died within 6 years of each other, right? And they were super young.
How many
right?
of them were there?
So there was Emily Branwell, who was that was a guy, that was their brother. There was Anne, and there was Charlotte. There was 4 kids, right? Emily died in 1848. Branwell died in 1848. Anne died in 1849. Charlotte made it to the ripe old age of 38 in 1855. Do you know why they think they died?
Something genetically?
It was, well, not really. They lived downhill from a cemetery, and that cemetery was overstuffed and not properly, like, the people weren't properly put in the ground, right? So that water from the cemetery was getting into their drinking water. And so they spent a lifetime drinking this nasty, like bacteria-ridden water, and they ended up all dying of tuberculosis.
Wow, that really took HVAC-ology to a dark place, Kelly. Thank you. Now let me audibly sip my water.
Go ahead. Your water is clean. Like, we are so fortunate to have clean water.
We are.
Mm-hmm.
I agree. Well, that was a rabbit hole. You
I told you.
You said it would be a rabbit hole. We've definitely gone down a rabbit hole. Kelly, got me choking now. I am excited about who we have on today. Mr. Todd Stovall, welcome.
Thanks for having me, Ryan, Kelly. I appreciate to be here.
Yes, and Todd is a representative and works for a company called Price Industries. And today we're going to get to hear about Price, the history of Price, and their leadership and kind of what they're doing for the community, what they have to offer to engineers and users, and then also how they give back to the community as well. And we'll hit up a couple of other things as we go along with that. But Todd, one of the things we like to do is we like to ask the people who are on, how in the world did you get from high school to today?
Yeah, I will say I am a listener to the podcast, so I appreciate you
Yay.
having me on.
All right.
And this has become one of my favorite parts. So I've thought long and hard about how I'm going to answer this question.
Okay.
So a couple little interesting facts. I actually grew up in the county where Price Industries North American headquarters, U.S. headquarters is based. I grew up 30 minutes down the road, went to a small high school here. Went to engineering school on the other side of town over in Marietta. If you look it up, the only thing that exists of my school anymore is a Wikipedia page because they merged it with a different university about 10 years ago now.
Hmm.
But I got my mechanical engineering degree, went to work for a company that was a machine shop. And actually, we just a job shop. I was doing G coding, CNC coding. There were about 12 people in the whole company. Left that, started looking for another job, found my way to Price. I still say I'm the only person who found a 10-year career out of Career Builder because I applied for a job at Price, started working here 10 years ago in June, and been here ever since. Loved it the whole way. So,
So Todd, what is the city and state that Price is located in?
yeah, so our U.S. headquarters is in Swanee, Georgia, just northeast, about 40 minutes northeast of Atlanta. So,
Okay. Very cool.
yeah.
And then I'm guessing that the person who founded Price was just a big fan of The Price is Right. Is that correct?
Yeah, a little bit different than that.
Sorry.
Yeah, no, yeah. Ernest Price was the founder of what is now Price Industries, and he actually started the company in Winnipeg, Manitoba, as a rep firm. So that the company started in Canada right after World War II, came back and started selling HVAC products to the local Winnipeg community.
Very cool. It's interesting to hear. You have a lot of companies that started, it seems like post World War,
Mhm.
and that's neat to hear. Price is a part of that story. So, what is if you would, just kind of take us through the origin story and where Price is at today.
Yeah, absolutely. So I'll start kind of in the middle and then I'll go back and come back forward for you. So it's really hard to talk about Price Industries today without talking first about our current owner, Jerry Price. So Jerry, he's the son of Ernest,
Hmm.
and Jerry is actually has a PhD from Lehigh University in Pennsylvania. And he had gone down the path of being a research scientist for the Canadian government and doing defense research on radio antennas and the effect of bomb displacement on radio antennas. Um, Not very long into his career doing that, Jerry Law, who was our second president at Price Industries after Ernest Price had retired, reached out to Jerry Price and convinced him to come back to his father's company and start working with his father's company. And so Jerry's science background is really kind of in built who we are today, and that's kind of still part of our identity and our dynamic. So I mentioned we started as a rep firm in the late 40s. We just celebrated 75 years in business,
Very cool.
and yeah, it's very exciting. Very similar timing for Hoffman and Hoffman.
That's true.
So we in the 60s moved into manufacturing under license for another brand in the Canadian market, and in the 60s and 70s kind of expanded our Canadian footprint across the entire country. So we have 19 offices, 19 sales offices across all of Canada today.
So, if you know the answer to this, great, and if not, we can move on from it. But that's really a curious thing. Like, how does a rep firm go to manufacturing? Did Jerry just see, hey, we can do this better kind of mentality?
It was, Canada's a long way up there. A lot of people don't realize how far it is from a lot of places, and so the quality of the product that they were receiving at the time
Hmm.
just wasn't up to what the customer's standards should be, and what the company felt like they should be getting. So that was why they decided to go into manufacturing on behalf of themselves, and that they could provide a better quality product in a more timely manner to their customers.
Gotcha. And now you guys have really grown as far as employee count and geography too, as far as what you can get out to.
Yeah, absolutely. So I mentioned Jerry kind of came back to the company, and that was in the late 70s, early 80s. Jerry Price kind of came back to the company. Jerry Law named Jerry Price the president of the company in 85, 86, right in there. And at that time, Jerry Price recognized that the opportunity for growth and expansion for the company was to move into the US. And
Mm.
so he took the opportunity to turn Price from a rep company and a rep business more into a manufacturing company as it's known today. So we started manufacturing under license or under our own brand, and moved into the U.S. market. And as you said, has just grown from there. So today the company sits at over 5,000 employees. There's 13 factories just in the North American market. And most of that is focused in the U.S. and serving the U.S. market. Jerry always likes to kind of say that the U.S. construction market grows by one Canadian construction market a year. So our growth path here in the U.S. is much higher. So it was a good opportunity
Mhm.
for him.
Yeah, wow, that's really
That's
cool.
amazing.
So when you first started out, were you just registers, diffusers when it first started the manufacturing?
Yeah, that was grills, registers, diffusers was the main business. With that, there was VAV boxes, terminal units, and that was really kind of the core business that started. When you started getting into the late 90s, early 2000s, we started building, hospital products, ceiling grid systems for operating rooms, really getting into the critical environments products. And then in about 2008, 2009, right in that area, started developing a whole variety of other products that we have today. So, and I know we're going to talk a little bit more about those as well, but started getting into noise control and duct silencers and acoustic panels, chilled beams, and displacement, underfloor, and a whole lot of other things.
So Todd, are you the guy now when you walk in with your friends to like a restaurant or a building, you look up and you're like, oh yeah, that's Price right there, diffusers or whatever.
You've been around this industry, haven't you, Ryan? Yeah, I
I have, yeah.
absolutely I absolutely am that guy. My wife gives me a hard time every time we go anywhere. She immediately is looking at the ceiling.
Yeah.
Uh, yeah,
Mafia guys, that when they walk into restaurants, they look behind their back to see if anything's happening.
yeah,
Nerds in the HVAC industry, we look up.
straight up, straight up. Yeah, yeah,
That's funny.
yeah.
So, we'll touch on some of the products, but what's kind of your ethos at Price to where you say, hey, we're going to get into noise control,
Mhm.
and what gets you to where you get into other business or at other parts of the HVAC business? Is it a curiosity? Do you say, hey, we can do this a little bit better? Like, what's the premise behind that?
Yeah, so the easy answer to that is yes. Jerry always kind of has this. He's very curious. I mean, I mentioned his science background and his curious nature. So as it's evolved over time, it's really just become if we think we can do that and serve that market better, and it fits within our wheelhouse, then it's certainly something we should explore and look into doing and go after. So. It usually starts with if we think we're going to go into something, we start by building a lab. So in Winnipeg, we have a 35,000 square foot research facility that is dedicated to understanding the performance and the requirements for all the products that we manufacture. And really, that's where it kind of all starts. If we think we can do something better or we can do it in a different way, then we start the research and figure out and prove it that we can, and then we start building it.
Mm.
That's cool.
Mm-hmm.
So in the products, I had a chance to take a look at your website, and I was really just impressed with just what you guys have as far as offerings. A couple of things that stuck out to me was the noise control capability that you have.
Yeah.
Kind of is that just there's a certain NC level that we're trying to hit in places just so that it's a creature comfort for people. It's not harmful to the ears. Kind of walk me through what you guys are doing as far as that's concerned.
Yeah, so building grills, registers, diffusers, and terminal units, it's a natural evolution to get into pieces of equipment that go into the ductwork in between those devices, right?
Hmm.
You create a sound when you introduce pressure drop, and you introduce pressure drop when you're using VAV boxes. So you might create noise, and as you mentioned, occupant comfort around noise levels. We've all been in that conference room that you can hear all the air distribution, blowing air around the room, or sitting underneath a rooftop unit that's rumbling, and we can kind of hear that in our spaces, and it can be very disrupting. So it made a lot of sense for us to get into manufacturing a lot of those products. It fit right in our wheelhouse. Built a lab, reverberant sound chamber to test it out. And now we have a whole line of duct silencers that are engineered specifically to the space that they're in. We even have a tool that allows you to mock up a sound and a space. So you can actually go in on our software and mock up from the air handler output to the room itself, and see how to attenuate that sound from source to zone. And so that's something that we're pretty proud of as well.
Very cool. I can remember whenever I was working for a consulting engineering firm, and one of the practices we had is if it was a very quiet room, we'd have to make the duct do what was called a pigtail, which basically is a big circle inside the under and up above the ceiling, so that would help with that noise attenuation. But what you're basically offering is the equivalent of like a silencer.
That's right. Yeah.
To put on it.
Yeah, it's a silencer's usually the most common way of addressing it or calling it. So it is a piece of equipment with engineered baffles and insulation in it that works the same way as your pigtail would, but in a little bit more compact and scientific manner. And we can actually measure the attenuation values, and there's an AHRI performance metric that we test to. So we know with this piece of equipment, how much sound we can pull out of any sound source. So it becomes very scientific very quickly.
Yeah, one of the reasons why we had to do that actually was in the hospital areas, because you had to have certain HIPAA rules to make sure you couldn't hear what the doctor was saying with the patient to the other rooms, and noise on a hard duct surface could travel over from one to the other depending on how it was designed.
Yep, it absolutely can. Yeah. So that's so we see a lot of those are called there's a lot of bit of science around sound transmission class, and making sure that you're reaching a certain level that it does get transmitted or can get transmitted wall to wall. It gets worse when you have an open plenum, meaning your return air, you're not ducted. You've just got an open space. A lot of people don't know this, but if you have a drop ceiling, like a acoustic tile ceiling, like you see in most offices, with the exception of the CEOs, the CFOs, and the critical people, the walls don't go all the way to the ceiling. They stop right at the drop tile ceiling. They don't go all the way to the structure. And so that's where you get a lot of those sound transmissions, is just in that open plenum space, because there's nothing there to stop the sound. So we have a whole suite of products around absorbing that sound and moving it in different ways to help reduce that transmission.
Yeah, where your other manufacturers are looking to provide a solution that sits on the ground outside or inside the mechanical room. You're really focused on the actual room where the people are physically present.
That's right. Yeah. That's the main focus is, you've got fans and you've got heavy equipment that's moving air through a building, and that creates a lot of sound. There's an opportunity to remove that sound in the ductwork before it ever gets anywhere into that occupied zone. But we have seen a lot of growth recently in a product that we call acoustic panels, and
Hmm.
those are just sheet metal panels with insulation in them. They can be perforated or solid metal, um, and they're built like a cabinet, for lack of a better term. They're built like an enclosure that can be used around equipment in large return air plenums, outside on outdoor structures. Ryan, I don't have to tell you, but centrifugal compression chillers are quite loud and
Hmm.
can generate a lot of noise going horizontally out of a space. So being able to build a barrier around that, and that's a product offering that we've seen a lot of growth in as well.
Yeah, there's buildings you can walk by and you can say, "Yep, that's a screw chiller," or "Yep, that's
Yeah,
a
that's right.
centrifugal." So yeah, very cool. But well, just quickly, what I wanted to also hit on is displacement diffusers. Kind of, what are those, just high level?
Yeah, so displacement is a concept that I don't think a lot of people have had the opportunity to see or experience. The general idea of a air distribution system in 90% of what we design and see today is what's called overhead mixed air, meaning we're bringing the air in from the ceiling and we're mixing it into the room, mixing the entire room, floor to ceiling. We're mixing that whole volume. Displacement, instead of delivering at the ceiling and trying to mix the entire space, we actually deliver at the floor, and we do
Hmm.
it with a lower air volume, oftentimes with a slightly elevated supply air temperature. And we do it at a low velocity. And the idea is that the air actually kind of trickles in and fills the room. And then you let natural heat sources drive air motion. So a computer or an occupant, we all have what's called a thermal plume.
Hmm.
As you sit and the air around your body gets warm, it accelerates and moves up the top of your head. And so we're using that idea to drive the air motion. So all the fresh air gets delivered to those heat sources. Meanwhile, you just keep filling that room from the floor and then exhausting from the top. And there's a lot of science around it now,
Yeah.
Ryan, where that there's increased occupant comfort because the air is treating the occupant directly. You're not mixing the entire space. And there's also an increase in air quality because all that fresh air is being directed directly at the person as opposed to trying to mix the whole room. So there's an opportunity to remove contaminants, particulates, CO2, things that make us sick and make us uncomfortable, get exhausted and pulled straight away out of the room rather than being mixed in with each other.
Yeah, allowing stratification to kind of take place to
That's
be
right.
able to pull out of everything. And then, there's a lot of surgery centers actually that they like to have it designed that way to where the air comes in low and then pulls out from the top. Because uh, I found out by having to design surgery centers that you actually have to maintain a certain humidity because if you're opening up a body cavity or whatever it is, you can't have that dry out. And so you have to keep maintain humidity within that space.
That's right. Yeah, there's a lot of displacement principles in spaces like that, as well as clean rooms, microelectronics manufacturings, everywhere that they build all of our phones and all the electronics that we use. They're using very similar design strategies, and it's all kind of the same focus. You're
Hmm.
trying to remove those contaminants, particulates, and keep the occupants safe and comfortable.
Yeah.
Yeah.
Very good. Thank you for that. And then also chill beams, that chill beams was something when I first saw them come out, oh man, like 2000-ish, 2001. I was so excited about it. I was like, this is a great idea, but it seemed like the industry really didn't catch on to it. And chill beams basically is just each room has like a 4x2 little chill water piping that's running in it, and then what happens is there's no fan or anything associated with it, and then that the air moves over that cold coil or whatever that's in there, and
Hmm.
it naturally cools things down. But the problem is that you have an issue with trying to wring out humidity, and
Hmm.
especially somewhere like South Carolina, you can have a little bit of issues, and so we tried to get to where we were designing around the perimeter to where we would get everything comfortable and then pulling that humidity out and then let the core be something like chilled beams. But anyway, what have you found like that product? What is your thoughts with that product?
So, you did a very great job summarizing the issues that we had when they first were introduced into the market here in the U.S. They really come from Europe, and
Hmm.
they do it quite often in the European market. And what they found when they brought it to the U.S. is we have a lot more water in the air
Hmm.
than most places. So, but as building facades and control strategies and understanding of humidity, coupled with desiccant wheels and DOAS air handlers that are more designed to treat the latent loads that we have, the requirements that we have in our buildings and in our outside air. We've started to see chill beams take a stronger foothold.
Hmm.
And it's interesting that you say, South Carolina is not a place that you would want to necessarily do it. Georgia, Florida, and North Carolina are three of my bigger markets that we see chilled beams being applied,
Wow.
because they can be done. So yeah, it's just all about how you make sure you control it, right?
Yeah, I agree. If the building is engineered well and the architect did a good job with it, it can be a fantastic solution. But
Yeah,
yeah.
absolutely. Well, and to further that point, with the standards of electrification and looking for energy efficiency coming through products like chilled beams, where we can introduce water,
Hmm.
water being more efficient at transferring heat energy than air, we can actually use less energy by using things like chilled beams, or displacement for that matter, as well as fan powered boxes with sensible water coils. So there's a lot of ways we can kind of use water to our advantage to help reduce our energy consumption.
Yeah, I agree. It's from a green standpoint, from an efficiency standpoint, I do love the idea of chill beams. But
Hmm.
yeah, that's great. Um, and then next, if we could kind of sit for a little while on critical technologies and the movement
Hmm.
of electrification that you just mentioned, kind of walk me through what Price's stance on that and what you've been doing in that
Yeah.
market.
Yeah. So really it comes down to educating the engineers as to what options they have for how to meet this really strict requirement that's coming. And we hear a lot about electrification. A lot of people are talking about it. It's a big buzzword in our industry right now.
Yeah,
Um,
Todd, real quick, before you go on, kind of walk me through what that strict requirement is that you just mentioned that's coming.
Yeah, so it really kind of started in the Washington state area, where
Hmm.
they were looking at energy consumption and how buildings use electricity. It also is looking at how do we build a building to reduce our carbon footprint. And a big part of the carbon footprint is the amount of electricity that we use in a building. So how do we reduce the amount of electricity that's going into a building? And it started in Washington, where they actually started requiring decoupled ventilation systems, meaning decoupling your sensible cooling from your latent cooling. And that allowed them to use things like high efficiency heat pumps that use less energy to generate the same cooling and heating output that a building might have already had, compared to a traditional system. So it really is all around how much electricity are we using, and then how do we prepare for a lower energy consumption from our existing grid and infrastructure.
So is that a governing thing that's coming down? Like, do you feel like is that something from a federal level or?
It's kind of state by state, as we see with a lot of these standards. Washington was kind of the first. Most of the West Coast has adopted some form of electrification standard, reducing electric consumption, and how we reduce our electric footprint. We've also seen it kind of take hold in the Northeast as well. But there are some, standards that are driving that as well, and it's just as more states adopt them, we'll see it, make a bigger splash. The ASHRAE standards have started to 90.1 is starting to adopt more parts of those codes as well.
Mm-hmm. So it kind of sounds like a rebranding of what was the hot thing for a while of LEED certification. Is what that sounds like. Very good.
Yeah.
So kind of walk me through. I'm sorry, I had you hit pause on where you were going with it. So we were talking critical technologies, and we talked electrification, and then I had you hit pause to explain that a little bit.
Yeah.
If you could go ahead.
No, it's okay. Yeah, so just in terms of what we're doing at Price to try and go down that path is just to help educate the engineers as to what that new version of that standard looks like. And there's still a large portion of the country that's on older versions of 90.1. And as they continue to start adopting these newer versions, it gets harder and harder to meet your, electric requirements. And so being able to provide opportunities to use different technologies, whether that be chilled beams, displacement. I mentioned the series boxes with sensible water coils, fan powered boxes where we can decouple our sensible cooling from our latent cooling, and really spread the part loads. So the idea here is that instead of cooling the entire building the entire time, we're cooling, an occupied zone, while an unoccupied zone we allow to not get hot, but get warmer, because we don't need to be focused on conditioning and cooling that space when there's nobody utilizing it. So that's really the main strategy within our industry is how do we educate people on what are their options for solving an ASHRAE standard and something that's coming down their way.
Yeah, something kind of nerdy that I've gotten into recently. I actually had somebody who was working on an invention. I signed a thing that says I can't talk about it, but I can't talk about his specifics. But what I can say is that it's a personalized cooling device that's very compact and small that keeps the individual cool, so that you don't really have to worry about what the room condition is so much, or like if you're in a building or if you're at a baseball game or whatever. So it's kind of neat, I guess, to your point of like we're pushing as an industry into this direction of how do we become more efficient? How do we think in different ways and different boxes?
Yeah, you're absolutely right. And you made a great point too with the lead as well, because a lot of it comes down to individual control, right? I personally want my office to be 60 degrees. You might like yours at 100 degrees. And the way we traditionally do air distribution and air conditioning, that's pretty difficult to achieve when we're occupying the same, 12 square foot area, right?
Mm-hmm. That's right.
I have a quick question about the electrification point there. So there are a lot of buildings around, and is it easy to retrofit these buildings to enable a more efficient energy usage?
So interestingly, Kelly, sometimes it can be, and sometimes it can't be, just depending on the type of technology that you're going for. But we've talked a lot about chilled beams. I'll stick with those for a minute. Really, your existing infrastructure from an air distribution standpoint, you're going to get smaller. So you're going to use less ductwork. You're going to use smaller air handlers. They're going to be more efficient. They're going to be more specialized, but really you're going to reduce your overall mechanical footprint. So a lot of these buildings that were, designed to old standards can still absolutely be utilized because you're actually shrinking your mechanical footprint. You might have to add a few things like chilled water or different approaches to adding those components, but there's usually space for that. We're able to fit into some very tight spaces that maybe aren't prepared for some larger systems that might be out there.
Okay.
So we have all these great products that Price has. Now, I was told, a little birdie told me that you guys have what is called the Epcot of HVAC. Kind of walk me through this tech center that is the Epcot of HVAC.
So actually, Ryan, we have two tech centers. So we have one here at the facility that I'm at in just north of Atlanta, which we call our Price Technical Center East. We have another one in our Phoenix, Arizona facility, which we call the Price Technical Center West. Those two facilities together equate to about 12,000 square feet of showroom. It's Epcot Center is a great way to put it. You come in and you can see all the different products that Price makes. You can see them operating and functioning the way they're supposed to function, and we'll even bring in people and train them on how to design, how to install, how you can really utilize these technologies and how they can be married together. So usually we bring somewhere in the neighborhood of 10 to 15,000 visitors through our facilities or through webinars, touch points every year. And so we do make an effort to educate the industry.
That's great. And that education is engineers and technicians, potential building owners as well, I'm sure.
Absolutely. Yeah. Yeah. We bring in all kinds of different people from all walks of life. Recently, we've started bringing in, high school engineering students just to show them in HVAC and get them excited about our industry. And as we all know, we're trying to bring more people into it. So we've partnered with local area high schools to bring in engineering programs and walk them through our facilities. Yeah.
That's great.
Yeah.
One of the things that I was really impressed with, just some of the research I've done into Price, is that your research and development, just the fact that you guys are very keen on making sure you put money back into the business, which I think is the reason why you got beyond registers, grills, and diffusers. Kind of walk
Yeah.
me through kind of your heart on that as Price Industries.
Absolutely. Jerry's a very humble man. He likes building, and he talks about being builders. We all kind of take on this builder mentality. And really what that means is that Price is privately held by Jerry and his family, with a few key shareholders amongst the executive leaderships and things like that. And what that really means is that we're all functioning like it's our business, and Jerry's philosophy is to invest and grow and build. So you talk about the research. I mentioned earlier the 35,000 square foot research lab in Winnipeg. All of our product catalog data comes out of that lab. Every Price product that we publish information on, we've tested it thoroughly to make sure that those numbers that we publish are exactly where they should be and are competitive in the market and serving the industry as best they can be. But it goes beyond that. It also goes into our manufacturing facilities as well. I mentioned 13 factories. There's 4 here in Atlanta. All 4 of those factories have state-of-the-art technologies, robotic manufacturing processes, advanced lasers, bending machines, forming machines, tool changers. We're really investing heavily into growing our capabilities within the existing footprint that we have. And a big part of that too is staying here in North America. We want to stay a company that manufactures. We don't want to. It's driven purposefully that we are going to stay here in the U.S. and in Canada forever.
That's cool. So in the days of when I was working for a consulting engineering firm, one of the things that I loved to do was to reach onto this shelf and to grab down this big book, and I could touch the pages and I could flip and I could read all the product data, and I could have little tags in there to know bookmarks that I could have to go and reference different things. Then all of a sudden it all went away. People would start sending their CDs, and then they started sending their jump drives, and then they started saying, go to our website. But Price I was actually in probably like a few months 6 months ago. I was in the Charlotte, North Carolina office, and I saw in the corner these boxes, and I'm very nosy, right? Nothing. So I go and I look in there, and sure enough, it's boxes loaded down with Price Engineering handbooks.
Mhm.
Kind of why is Price that company that still has that book out there?
So, there's two different books out there, and so
Yep.
I'll touch on both of them real quick. You specifically saw the Engineer's Handbook, and really that's actually a different approach. So the Engineer's Handbook is all about educating the market. So that book is a college textbook, for lack of a better shorthand for it. It's a book that we've invested heavily in that talks about engineering concepts, has examples of how to design different systems, how to understand how noise moves through a room, how to do the things that we do in our industry in a textbook format. And so that book is very much a grassroots strategy to reach out to engineers and be a part of their everyday workflow. I think two of my favorite things about that book is there's no mention of price product in the engineer's handbook. It's all just engineering.
Hmm.
And it's also got 108 PDH credits as you go through the book. So anybody who needs their credits, you just get your hands on the book and you're good for quite a while. Um, as far as the catalog goes, we still do publish a printed catalog, physical catalog, and we recognize that there's a lot of engineers out there like you, Ryan, that like to have a physical hard copy handbook and want to be able to touch and feel and flip through and look at what's in the catalog. I find it interesting every time we publish a new one. Jerry reads every single page, looks at every single page, red lines every single page. And that's just the science side of him, right? The research side of him very much just wants to be understanding and know that the information that's in that book is solid and based on scientific fact. And the other thought process there is if we publish a hard book, we have to make sure it's right. We can't publish a book out there and then retract, 30,000 copies of that book 6 months later, right? So.
Yeah. Yeah, you got to have the formulas right. I tell you, I couldn't watch it. I watched like two episodes of The Big Bang Theory, and they had Schrodinger's equation wrong, and I had to cut it off. I couldn't watch it again.
Yeah, yeah,
So, engineering mind people, you can't fool them.
that's right. That's right.
Very cool. So, I heard this word, and it's the first time I've heard this phrase was when I was talking with you guys, was this forever company idea.
Yeah.
So what is this forever company that is Price, and walk me through what that means to you?
Yeah, absolutely. So we've kind of touched on a few of those pieces along the way, but Jerry Price and his family are still the primary shareholders of the Price family of companies, which today, is a $1.4 billion revenue company with 5,000 employees. Jerry talks about it every year. He does, I'll call it the State of the Union, State of Price address, that he comes in and speaks to everybody and just kind of gives an update on the company. But it's very important to Jerry that there's a legacy here of a company that we all know we can send our kids to work for, that there's people that care in the community and that we're part of the communities that we're in. So Jerry's set it up such that the Price company can never be sold to private equity, can never be sold to an investment firm. It's just going to continue to be family owned and operated. And that includes a group of shareholders. As I mentioned, a lot of the leaders within the company, about 100 or so of the main leaders within Price Industries, are all shareholders, and really it's an opportunity for Jerry to give back to those people and for those people to feel important to the ownership of the company and the process by which the company moves forward. Interestingly, in terms of like the Forever Company, part of that legacy as well is the Price Family Foundation. So every year or so, every other year or so, that the shareholders might get paid out small portion of dividends. And that's really so Jerry can give back to the community. Those dividends go out to healthcare or poverty reduction or education in the form of the Price Family Foundation. And over the last 10, 15 years, the Price Family Foundation has donated over $30 million
Wow.
into the community in Winnipeg, here in Atlanta, in Arizona, and other areas where we have a footprint. So.
You know what I like about what you said there, Todd, is that whenever you give to a local need, and that way you get to see how that affects and the ripple effects that happens in your local community. That's great to hear.
Yeah, yeah, and it provides a sense of pride and ownership of all the Price employees. We all feel a sense of this is it's our business and it's our company and it's our community, and it's a way for all of us to be there for our customers at the end. Yep.
Mm-hmm. That's great.
Mm-hmm.
Well, very good. Well, Todd, thank you so much for taking some time to tell us about Price Industries. I've loved your company for a long time. I'm so glad we finally got to sit down. And by the way, so everyone's listening, Todd told me earlier that I'm welcome to come and tour their facility.
I heard it.
Yeah.
So I always tell everybody you're welcome anytime. You might walk yourself through the facility by yourself, but the doors are always open. So come see us in Suwanee, go see us in Phoenix, Arizona. If you're willing to make the trip, Winnipeg is an awesome trip to make, especially for those of you that like hockey, going up there in the winter time to go see a hockey game. If you've never experienced minus 40 degrees, which, by the way, it doesn't matter which temperature scale you're using, minus 40 Celsius and Fahrenheit are the same number. So
That's right.
Yeah. So there's my useless piece of information for you for the day.
It's very useful if you're in minus 40, though.
That's right. That's right.
Right.
So, but yes, any of our facilities, you're welcome to come anytime.
Yeah. That minus 40 degree temperature. So I was in Scotland going up into a loch, and this buddy of mine had an old Land Rover, and he was like, hey, we're going to go up there and we're riding. I'm like, man, turn the heat on. And he's like, this doesn't have any heat. And so that was terrible. I've never felt my bones cold. I've felt my bones cold.
That's right. Yeah. It just penetrates everything. Yeah.
Yes, it does. Well, cool. Kelly, before I ask you if you learned anything new, the thing that I'm going to say is how I know that Price is going to be around not just today, tomorrow, but for a very, very long time is because these guys are a bunch of cool nerds.
Right? You're the best cool nerds.
We try to be. We try to be for sure. So I will say thank you very much for having me on. This was a blast.
Yeah, absolutely. Kelly, what'd you learn new today?
So fun for us. Well, obviously, wet bulb versus dry bulb. I'm never going to forget that again. But I also learned more about chilled beams. I did not actually understand how they worked, and I did not know how well they could work in the Southeast. So really great information.
Very cool. Well, thank you all, everyone out there, for listening in. And this one was a good one. I enjoyed it. Everybody take care out there. Bye.
Bye.
Took a rocket past Saturn. Things don't seem to matter much to me anymore. Got lost inside a daydream. Get sick of all schemes they play on their machines. I lost so many words as I got older. You would have thought I would have stored them in my new love folder. I accidentally wrote these words down. Thought all the best of me faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back inside, but you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me. I drove an hour to see you. Things just seem to matter more to me anyway. Got lost in reality, no answers to cancer, we never got to talk. Lost so many friends as I got older. Wish I had the strength to hold you a little bit longer. Always meant to write these words down. Thought all the best of you, faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me. Get your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside? But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back songs inside of me. You were always inside of me.